The illusion of internet. When your screen freezes and that little icon says no internet connection, you probably think the internet broke. Spoiler alert, the internet itself is fine. What actually happened is that somewhere between your device and the rest of the digital world, a link in the chain failed. Here's the thing most people get wrong. Your internet connection is not one thing. It is a series of different technologies, each with its own failure points, all pretending to be one seamless experience. You have the physical cable coming into your house from your internet service provider. Then you have the modem that translates that signal, then the router that distributes it, then the wireless signal if you are using Wi-Fi, then your device's network card, then the software on your device, then the servers you are trying to reach. Any one of these can fail independently, but your device will just shrug and say, "No internet like that explains anything." It does not. So when you blame the internet, you are blaming a system you do not understand for a problem you have not identified. Let's fix that. Wi-Fi signal versus internet signal. This is the most common confusion, and it costs people hours of troubleshooting time. Your Wi-Fi signal and your internet connection are two completely separate things. Wi-Fi is just a wireless bridge between your device and your router. It is a local network inside your house. The internet is everything outside your house. You can have perfect Wi-Fi with zero internet. You can also have perfect internet with terrible Wi-Fi. Here's how to tell the difference. If your Wi-Fi icon shows full bars but nothing loads, your Wi-Fi is fine. The problem is elsewhere. If your Wi-Fi icon shows weak signal or keeps disconnecting, that is a Wi-Fi problem, not an internet problem. Most people see connected, no internet, and immediately blame their internet service provider. Wrong. That message means your device successfully connected to the router via Wi-Fi, but the router cannot reach the internet. The Wi-Fi did its job. Something else failed. This distinction matters because the fixes are completely different. Restarting your router might fix an internet issue. Moving closer to the router fixes a Wi-Fi issue. Know the difference. Router overload and buffer saturation. Your router is not a magic box. It is a small computer with a processor, memory, and an operating system. And just like your laptop starts choking when you open 40 browser tabs, your router can get overwhelmed. Here is what happens. Every device connected to your router is constantly requesting data. Your phone is checking for emails. Your smart TV is streaming. Your laptop is downloading updates. Your security camera is uploading footage. Each of these requests gets stored in the router's memory buffer while it decides where to send the data. When too many requests pile up, the buffer fills completely. This is called buffer saturation. At this point, the router has two options: drop new requests entirely or slow everything down to a crawl. Either way, you notice. The problem gets worse with cheap routers that have minimal memory. They simply cannot handle modern household demand. 10 years ago, a household might have 3 devices online. Today, the average home has over 20 connected devices. Your router was not built for that. The result is random freezing, stuttering video, and that spinning loading icon that haunts your dreams. ISP drops and line noise. Sometimes the problem is not in your house at all. Your internet service provider can drop your connection without warning, and you would have no idea why. Here's what happens on their end. The physical line running to your house, whether it is copper, fiber, or coax cable, carries an electrical or optical signal. That signal can degrade for dozens of reasons. Water seeps into a junction box. A squirrel chews through insulation. A construction crew accidentally nicks a cable 3 blocks away. Temperature changes cause connectors to expand and contract. Any of this introduces what is called line noise, which is interference that corrupts the data signal. Your modem tries to filter out the noise and reconstruct the data, but if the signal gets too degraded, it just gives up. Connection lost. Even worse, internet service providers often oversubscribe their networks. They sell more bandwidth than they actually have, betting that not everyone will use it simultaneously. During peak hours, when everyone in your neighborhood is streaming, the network gets congested. Your connection does not technically drop, it just slows to the point of being useless. And good luck getting your internet service provider to admit that is the problem. DNS failures. Websites not loading, but internet works. This one is sneaky. Your internet connection is working perfectly. Your router is fine. Your Wi-Fi is strong. But websites will not load. Welcome to a domain name system failure. Here's the deal. When you type a website address into your browser, your device does not actually know where that website lives. It needs to ask a domain name system server to translate that human-readable address into an IP address, which is the actual numerical location of the server. Think of domain name system as the phone book of the internet. If the domain name system server stops responding, your device cannot look up where to go. So even though your internet connection is active, nothing loads. You can still ping IP IP addresses directly if you know them, but good luck remembering the numerical address for every website you visit. The frustrating part is that your device will tell you the internet is working. Technically, it is, but from your perspective, everything is broken. This happens when your internet service provider's domain name system servers go down, which is more common than it should be. It also happens if your router cached an outdated domain name system entry and refuses to let go of it. Either way, the fix is simple. Change your domain name system servers to something reliable like Google's or Cloudflare's. Problem solved. 2.4 GHz versus 5 GHz interference. Your router broadcasts Wi-Fi on specific radio frequencies, and those frequencies are a crowded mess. Most routers use the 2.4 GHz band because it has better range and penetrates walls more easily. The problem is that literally everything else uses 2.4 GHz too. Microwave ovens, baby monitors, cordless phones, Bluetooth devices, wireless security cameras, and every single one of your neighbor's routers are all screaming on the same frequency. The result is interference. Your device tries to hear your router, but it is like trying to have a conversation at a rock concert. Signals overlap, data gets corrupted, packets get dropped, and your connection stutters or dies completely. The 5 GHz band is less crowded and offers way more channels, which means less interference. It also delivers data faster. The trade-off is range. 5 GHz does not penetrate walls as well, so you need to be closer to the router. If your router and devices support it, switching to 5 GHz will solve most interference problems. You can also manually change the channel your router uses within the 2.4 GHz band. Download a Wi-Fi analyzer app, check which channels are least crowded in your area, and switch to one of those. Device congestion. Every device on your network is fighting for bandwidth, and most of them are terrible at sharing. Your smart TV is downloading firmware updates in the background. Your phone is uploading photos to the cloud. Your smart thermostat is sending data every few minutes. Your security cameras are streaming video 24 hours a day. Your smart speaker is listening for wake words. Your gaming console is downloading a 50 GB patch. None of these devices coordinate with each other. They all just grab as much bandwidth as they can, whenever they want it. This creates what is called network congestion. Even if your internet connection has enough total bandwidth, your router has to manage all these simultaneous requests. It prioritizes traffic based on protocols you probably never configured, which means your video call might get throttled while your smart fridge updates its software. The Internet of Things made this problem exponentially worse. 10 years ago, you had a laptop and maybe a phone. Today you have 15 smart devices that constantly talk to the internet, and most of them are horribly inefficient. They were not designed with network courtesy in mind. They just consume bandwidth and hope for the best. Your router drowns in the chaos. IP conflicts and DHCP weirdness. Every device on your network needs a unique IP address, which is like a street address for data delivery. Your router assigns these addresses automatically using something called Dynamic Host Configuration Protocol. Most of the time this works fine, until it does not. Here's what goes wrong. Your router maintains a list of which devices have which IP addresses, and it leases these addresses for a specific period of time. When the lease expires, the router expects the device to request a renewal. But if your router gets overloaded or reboots, it might forget which addresses it already handed out and accidentally assign the same IP address to two different devices. This is called an IP conflict. Both devices think they own that address, so when data arrives, the router does not know where to send it. Result: neither device can connect properly. Another problem happens with dynamic IP addresses from your internet service provider. Your provider assigns your modem an IP address temporarily. When that lease expires, they give you a new one. If your router is busy when this happens, it might miss the update and keep trying to use the old address. It is like trying to receive mail at your old apartment. Your router screams into the void, but nobody answers. Background updates destroying bandwidth. You think you are just browsing the web, but your devices have other plans. Operating systems love to download updates in the background without asking permission. Windows Update is notorious for this. It will suddenly decide that right now, in the middle of your video call, is the perfect time to download a 3 GB update. Your computer does not tell you. It just starts eating your bandwidth. Your video call freezes. Your music stops buffering. Your game starts lagging. You have no idea why until you check Task Manager and see the network usage maxed out. Smartphones do the same thing. Apps update automatically. Cloud services sync files. Photos upload to backup services. All of this happens silently in the background, consuming bandwidth you thought you had available for other tasks. Gaming consoles are even worse. They download massive patches, sometimes 50 to 100 gigabytes, and they do it whenever they feel like it. Most people never configure bandwidth limits or scheduling, so these updates just run wild. The router sees all this traffic and tries to handle it, but it cannot prioritize what matters to you versus what your devices decided matters to them. Your connection grinds to a halt, and you blame the internet. Why restarting the router magically fixes it. Turning your router off and on again feels like a dumb solution, but it works for legitimate technical reasons. Here is what actually happens when you restart it. First, the router clears its memory. All those stuck requests, corrupted packets, and overloaded buffers get wiped clean. The router starts fresh with an empty slate. Second, it reestablishes the connection with your internet service provider. If there was a communication error or an IP address problem, restarting forces both sides to renegotiate from scratch. Third, it resets all the network tables. Your router maintains lists of connected devices, IP addresses, routing paths, and active connections. Sometimes these tables get corrupted or outdated. A restart rebuilds them correctly. Fourth, it stops any processes that were stuck in loops or consuming too many resources. Your router's operating system can have bugs just like your computer. A restart kills those buggy processes. Fifth, it forces all your devices to reconnect and request new IP addresses, which resolves conflicts. The wait a few seconds part matters too. Capacitors inside the router need time to fully discharge. If you plug it back in too quickly, residual power keeps some systems active, and you do not get a true reset. The real bottleneck you never see. Everyone obsesses over internet speed, but speed is not usually the problem. The real bottleneck is latency and packet loss, and most people have no idea these exist. Latency is the time it takes for data to travel from your device to a server and back. Even if you have gigabit internet, high latency makes everything feel slow. You click a link and nothing happens for a full second. That delay is latency. It is caused by distance, network congestion, and the number of hops your data takes through different routers. Packet loss is even worse. Data does not travel as one continuous stream. It gets chopped into little packets, sent separately, and reassembled at the destination. If some packets get lost along the way, your device has to request them again. This causes stuttering video, choppy audio, and websites that partially load, then freeze. You can have 500 megabits per second download speed, but if you have 10% packet loss, your connection will feel broken. The problem is that standard speed tests do not measure this properly. They show you big impressive numbers, but they do not tell you about the constant micro interruptions destroying your actual experience. Your router has no control over most of this. How to know what actually broke. Stop guessing and start diagnosing. Here is how to figure out what actually failed. First, check if other devices can connect. If your laptop cannot load websites but your phone can, the problem is your laptop, not the internet. Second, check the router lights. Most routers have indicator lights that tell you exactly what is working. Solid green usually means everything is fine. Blinking amber or red means something failed. Check your router's manual to decode the lights. Third, run a ping test. Open a command prompt and type ping 8.8.8.8, which is Google's public domain name system server. If you get replies, your internet connection works. If it times out, the problem is between your router and your internet service provider. Fourth, check if it is a domain name system problem. Try pinging an IP address directly. If that works, but websites do not load, your domain name system is broken. Fifth, use a Wi-Fi analyzer app to check signal strength and interference. If you see a dozen networks on the same channel, that is your problem. Sixth, log into your router's admin page and check connected devices. If you see 30 devices when you only own 10, someone is stealing your Wi-Fi or your Internet of Things devices went rogue. Speaking of myths, that video on screen covers every major technology myth you probably still believe.